Hello everyone, welcome back to my Mind Gets Motivated channel. So, as you all know, I have told in my last video that from next video onwards, I'll be starting short videos on very important topics. So, today, from pharmaceutical analysis topic. Okay, so we will be discussing methods of expressing concentration. Okay, so methods of expressing concentration. Usually, if you take, for example, in a beaker, you wanted to make around a 10% sodium chloride solution. Okay, so if you want 10% sodium chloride solution, you should know how much sodium chloride you should add and how much water you should add. Am I right? So, for knowing this, you should know methods of expressing concentration. So, you should know either we should concentrate, either it is a solid or a liquid, in what way we should express, and how much quantity we should add. So, you should know that. So, to know that, scientists and researchers have found some basic terminology or some basic methods of expressing concentration. So, let's start this. So, we have first one, percent solutions. Okay, so here we have three types again. First one is percentage weight by weight, that is mass percentage. Okay, the next one is percentage volume by volume, that is volume percentage. And the last but not the least, that is percentage weight by volume, that is mass by volume percentage. Okay, so let's see each and everything now. So let's see the first one, percentage weight by volume. Okay, so as you have seen percentage weight by volume, so it is nothing but if you take a solute A in B solvent. Okay, so that makes your A plus B solution, right? Yes. So how do you express this percentage weight by volume? So if you see, it is nothing but the, as I have told you, it is the mass percentage. So now mass percentage of A is mass of solute A by the total volume of solution into 100. Okay, the next one, it is percentage weight by weight. Oh sorry, this is, I forgot, this is mass by volume percentage. And if you see percentage weight by weight, so that is mass percentage. So how do you say it? Say same example, solute A in B solvent gives you A plus B solution. So this is mass by volume percentage. So now this is mass percentage. Now if we say mass percentage of A, mass percentage of A is mass of solute A by total mass of the solution into 100. Okay, so this gives you your percentage weight by weight. Now next let us see the percentage volume by volume. Okay. Now next let us see last but not least, that is the percentage volume by volume. So it is nothing but our volume percentage. So same thing, solute A plus solute B, solvent B gives us A plus B solution. So if you want to calculate volume percentage of solute A, so it is nothing but volume of A by total volume of the solution into 100 gives you percentage weight by weight. Now let us take an example to understand the percent solution. Okay, so I'll be taking one example. Let's see this. Raju wanted to prepare a 20% weight by volume solution of sodium hydroxide in water. Okay, so how many grams of NaOH is required to make 20% solution? Okay, so this is the question. So how do you solve it? So solution. Okay, so what they have given? They have given 20% weight by volume. So what is the formula of this? Mass. Okay, that is mass of A by total volume of solution into 100. Okay, so that is 20 they have given. So how do you solve it? So they have given already 20, right, is equal to mass, let us take it as X, and total volume, usually if they have not mentioned, let us take it as 100 ml. So to make a 20% of 100 ml solution of sodium hydroxide, how much is the weight required? Okay, so total volume is 100, let us take, okay, into 100. So this 100 gets cancelled, and X is 20 grams. Okay, so it is required that 20 grams of sodium hydroxide is required to prepare a 20% of 100 ml NaOH solution. Okay, so I hope you got this percent solutions very easily. Okay, so in the last I'll just summarize all the formulas, just make a note of it. Okay, now let us see the four methods of expressing concentration. The next one is the molarity. Okay, so it is defined as number of what you say, number of actually it is number of moles. Okay, so number of moles of dissolved solute in 1 liter of solution. Okay, so it is usually expressed as M. Okay, so if we see what is the formula of it, M is equal to N by V, where N defines number of moles, okay, V defines volume of solution, usually in liters. Okay, so the other formula is you see M is equal to, number of moles is usually, you all know, weight by gram molecular weight. Okay, so weight by gram molecular weight into 1 by volume in liters, or you can also write it as V is equals to weight by gram molecular weight into 1000 by volume in ml. So these are the very important formulas. Okay, so just make a note of it. And there is also another formula where if you know two molarities and if you want, and if you know only one volume, so if you want to get the other volume at particular concentration, so you can use the formula M1, the same substance. So therefore the number of moles remains constant. So therefore if you just cross multiply, M1 V1 is equals to M2 V2. So if you see what are the units of it, units, it is number of moles by volume, right? So number of moles is nothing but the gram. So usually the units are like mole per liter, or usually you can write mole per liter inverse. Okay, yeah. So next let us see the normality. Normality is also similarly like molarity only, but here we use gram molecular weight, but there we use gram equivalent weight. So that you should see, okay, that you should remember. So if we write normality, so it was the number of moles, but here it is the number of gram equivalents. Okay, so I'll just explain gram equivalents, okay, of solute in 1 liter of the solution. So it is usually expressed as N, where N is equals to number of gram equivalents by volume of solution in liters. Okay, so there are other formulas where you can see it, N is equal to weight by gram equivalent weight into 1000 by volume in ml, or N is equals to weight by gram equivalent weight into, into 1 by volume in liters. So it is also same like molarity, where N1 V1 is equals to N2 V2. Okay, so what are the units means? Gram equivalent, usually equivalent per liter inverse, like that it is. Okay, and yeah, so next there are more two methods of expression, expressing concentration. The two left ones are like, one is molarity, one is molality. So you may get confused with molarity and molality, but don't get confused. Okay, so it is molality, not molarity. So molality is number of moles of solute in 1 kilogram of solvent, but not solution. So that you should remember. So it is usually expressed M, small m, is equals to number of moles by volume in kg of what? Of solvent, but not solute. So this remaining all is same. So if you want to write this, M is equals to weight by gram molecular weight into 1 by volume of solvent in liters, or it is also weight by gram molecular weight into 1000 by volume in ml. Okay, so here the units are like mole per kilogram inverse. Okay, so next, the last one, which is very easy, mole fraction. Okay, so here I'll be explaining two problems, so that in the next coming years, when I'll be starting the GPAT, previous year questions or some sample questions, so you should be able to solve that. Okay, so next, the last one, that is the mole fraction. So here, if we take a solute A plus solute B, okay, so it is usually expressed in the form of like cross X. Okay, so mole fraction of A plus mole fraction of B is always equal to 1. There may be how many solute particles, whether it is A, B, C and so on till Z. Okay, so XA plus XB and so on till XZ, mole fraction is always equal to 1. Is always equal to 1. So what is actually mole fraction? So if we take mole fraction of A, so it is number of moles of A by total number of moles of the solution, that is Na plus Nb. And if you take mole fraction of B, so it is number of moles of B by Na plus Nb. So always these both are equal to 1. Okay, so these are the 5 the methods of expressing concentration formulas. Okay, so I'll just explain one problem we'll solve. Okay, so two problems. So you see, 40 grams of sodium hydroxide in 250 ml of water. What is the sorry for this interruption. So if you see 40 grams of sodium hydroxide in 250 ml of water, so what is the molarity? So M is equals to, what is the formula? Now weight by gram molecular weight into 1000 by volume in ml. Okay, so M is equals to 40 by 40, because gram molecular weight of sodium hydroxide is 40 into 1000 by 250, right? So it is cancelled once, fours, so molarity is 4 molar. Okay, so one more problem we will solve, where it is based on the mole fraction. Okay, so this is easy only. If you just remember the formulas, you can solve any problem here. Now, based on mole fraction. Now, number of moles of solute given is 3. Number of moles of solute B is 5. What is the mole fraction of A, of B and A plus B? So as you all know, I have told you earlier how many solute particles will be there, but the mole fraction of all the solutes will be 1, right? Now let's calculate mole fraction of A. What is the formula? Na by Na plus Nb, right? So it is 3 by 3 plus 5, so it is 3 by 8. Okay, now what is the mole fraction of B? Nb by Na plus Nb. Okay, so that is 5 by 8. So if you just add up these two, this 5 by 8 plus 3 by 8 is 8 by 8 is equals to 1. Okay, so I hope you all understand what is mole fraction, what is molarity, what is normality, what is molality, and what is percent solutions. So I'll just briefly summarize what all I have discussed in this video. So that is percent solution, where I have discussed percentage weight by weight, percentage volume by volume, percentage weight by volume. Then I have discussed molarity, Okay, then I have discussed normality, then I have discussed molality also, and at the last I have discussed mode fraction. Okay, so if you find any difficulty, please ping me or please do comment in the comment boxes. Okay, so thank you for watching very patiently, and I'll be back with another important video for the GPAT exam in the next one. Please like, share and subscribe our channel, where mind gets motivated. Bye guys.